Hi all, welcome to the YouTube channel Raise Online. Today we are going to discuss about some questions from the topics modern physics, ray optics as well as wave optics. So let us start with the questions. So here are some questions displayed here. You can go through the questions. The first question is that is from dual nature of matter and radiation. Hope you must be familiar about the dual nature of matter and radiation topic and those concepts in that topics. So let us start with the question. The first question is the number of photons per second on an average emitted by the source of monochromatic light of wavelength 600 nanometer when it delivers the power of 3 by 10 raised to minus 3 watt will be. So they were asking us a question that how many photons per second on an average emitted by the source. Since you are aware about the wavelength of the monochromatic light, that incident, so that it is possible to convert that wavelength into energy form, since you know that the energy associated to a photon is equal to h nu. You are familiar with this. So that this h is Planck's constant, nu is the frequency of the incident photon. This can be rewritten into this form hc by lambda, since frequency is equal to c by lambda, where c is the speed of light and lambda is the wavelength. Since in the given question they have given hc by lambda is given in 600 nanometers, so it is given in 600 nanometer. Since we know the some shortcuts how to convert a particular wavelength into energy form, then this 600 nanometer can be converted into energy form by using some kind of shortcuts we have. So according to that, see here, this h value is a constant, so we will use the h value as 6.6 into 10 raised to minus 34 joule second, and the c value is 3 by 10 raised to 8 meter per second whole divided by 600 into 10 raised to minus 9 meter. Okay, this is the elaboration of the given equation hc by lambda in this. So on solving this, we'll get the equation that we'll get the energy of the incident photon. Okay, so that this can be simplified in this manner also. If the given wavelength is in, see it is in nanometer, we can go for a shortcut there. And what is that shortcut? You can use this shortcut 1242 divided by 600 electron volt if the wavelength is given in nanometer. That means whenever you simplify all these terms and you want to convert it in electron volt, you know that 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule is 1 electron volt. Since you know that 1 electron volt is this much, you can substitute for this joule. Okay, this value 1.6 into minus 19 joules. So this value whenever you substitute, then you will find the answer in this format. So this will be approximately 2.7 electron volt. So this is the energy associated to this wavelength, that is 600 nanometer wavelength. Energy is 2.7 electron volt. So the question is how many or what is the number of photons emitted per second on an average by the source. So you are supposed to get the value of number of photons. Since you know that power is equal to work by time, you can rewrite it as energy delivered in unit second. So the energy associated to a photon is h nu divided by t. Then if there are n photons excess, you can rewrite it as n into h into nu divided by t. Then this n by t they were asking. This n by t I am rewriting as, which is equal to capital N into h into nu. So this is the picture which we are getting about the power delivered here. See, from this equation, you are supposed to get the value of this capital N. How much is capital N? So you can write the capital N is equal to power divided by h nu. Power divided by h nu. Since you know that the power is mentioned there in the given question, it is 3 by 10 raised to minus 3 watts divided by, and you know this value is 2.7 electron volt. So here watts is the SI unit of the power, electron volt is the unit of energy. Since okay, they are entirely different units, you are supposed to convert that electron volt into joule second, then only it is possible to simplify. So whenever you simplify this, you will get 3 by 10 raised to minus 3 divided by 2.7 into 1.6 into 10 raised to minus 19 joules you will get. Similarly, this one will be watt is equal to joule per second, then you will get the value of according that. So see here, this 10 raised to minus 19 went to the numerator, then you will find the 3 by 2.7 into 1.6. Okay, then this 10 raised to minus 19 will go to the numerator. There you will find 10 raised to plus 19. So you can write this is equal to 10 raised to, if this minus, okay, 10 raised to plus 16 will be the condition. Okay, so approximately the order is 10 raised to 16. And now look here, whenever you multiply 2.7 with 1.6, approximately these two values will be same. So you can just pick up that final answer as 10 raised to 16. So this is the answer to the question number 1, 10 raised to 16. So the number of photons emitted is equal to 10 raised to 16. That's the first case. So now question number 2. So in this question, let us see what is there. The photoelectric threshold wavelength of silver is 3250 by 10 raised to minus 10 meters. So there's some little variation in the edited material. So it is 10 raised to minus 10. Please note it, 10 raised to minus 10 is the concept. The velocity of the electron ejected from a silver surface by ultraviolet light of wavelength 2536 by 10 raised to minus 10 meters. So they were asking. So there are 4 choices given, and there they are approximation they were asking. So if it is an objective type question, usually we are going for approximation like what we have done with the question number 1. Now in this question 2, the actual part is what is the velocity of ejected electron from a silver surface of ultraviolet light of wavelength 2536 by 10 raised to minus 10 meter. Since you know that Einstein equation of photoelectric effect. Einstein equation, it says that kinetic energy is equal to h nu minus h nu 0. Here h nu is the energy of the incident photon, h nu 0 is the threshold energy or the work function of the material. So when a material having exposed to light having some energy h nu, then ejection of the electron depends upon the energy level of the incident photon as well as the minimum energy requirement of the material. So the material requirement is usually represented by phi 0. This is known as threshold energy or work function. So the minimum energy that required by this material to eject electron from their surface, or similarly we can say in another way also, the minimum energy that required by a photon to make it possible the ejection of electron from the surface. In that way also we can say. So this is the particular thing which you can notice in this case. See here, phi 0 is the threshold energy, h nu is the incident photon energy. Now the question is velocity of the ejected electron from the silver surface. See, one of the wavelength has given known as threshold wavelength. So in this equation, from this equation we can write h nu 0 is equal to hc by lambda 0. Okay, so this lambda 0 is the value which is given as threshold wavelength in this equation. So in this question, so it is 3250 by 10 raised to minus 10 meter. So this is approximately 3250 angstrom. Let us mark like this also, because always we have to go for an alternative method also, because we need some shortcuts to complete the process inside examination hall. So anyhow, I will show the both routes how to get the answer. So both routes will help you to choose which one is a good easy approach for you according to your level. Now see here, the wavelength of the incident photon is lambda. This value is approximately 3250 into 10 raised to minus 10 meter is given. So it is equal to 3250 angstrom. Okay, these are the wavelength of this which one incident photon. So this is not, sorry, it is not 3250, it is 2536. Lambda is this is 3250 angstrom and lambda is 2536 by 10 raised to minus 10. This is equal to 2536 angstrom. This is the wavelength of the incident photon. This is the threshold wavelength. So this is the difference between lambda and lambda 0. Now see here, they were asking you the value of the ejected value of the velocity of ejected electron from the surface. See, in this k value, in this k, you will find k is the kinetic energy. Usually it is equal to half mv square. Okay, half mv square. Since you know that this is the half mv square value, that means difference in the photon energy and the threshold energy. So let us do that one first, later we can see here. Here the concept h nu minus h nu 0 is equal to h nu is, this is the concept hc by lambda minus hc by lambda 0. Okay, here HC is common, so we can take it outside. And we have one more method. You know that HC is a constant. H is Planck's constant, C is speed of light. So that whenever the wavelength is given in, okay, with some units, we have some shortcuts to get the value of HC by lambda. So what I'll do here means, I'm going to rewrite this HC as 12423 divided by the value of lambda is 2536. Okay, this is so here the concept k is equal to h nu minus h nu 0. What I am doing here means h nu by hc by lambda minus hc by lambda 0. Okay, so that while converting this value into electron volt, we know that Hc replaced by 12,423 divided by lambda electron volt minus 12,423 divided by lambda 0 electron volt. This is one of the shortcut which you can. It is not necessary to follow this shortcut. You can do directly from here. Since you know the value of H, you know the value of C, you know the value of lambda. So all the values are given in the question. So you can directly substitute that value there and go ahead. But we are always thinking about how to minimize the time that we are spending with this question, so that we are going for some shortcuts, because this Hc value, since it's a constant, we have already made that calculation in this manner. Now look here, Hc can be 1242, Hc can be 12423. How it becomes so? The two reasons are, sometimes the given wavelength will be in nanometer, sometimes the given wavelength will be in angstrom. Since the given wavelength in this case is angstrom, so this is the coding which you can use for the Hc. Suppose if it's a given wavelength in nanometer, like in the previous question, there you can use 1242. That's enough for the calculation. Now look here, it is the concept 12423 divided by wavelength of the incident photon is approximately 2536. 2536 electron volt minus 12423 divided by lambda 0 is 3250. 3250 electron volt. So that whenever you simplify this, approximately 2536 is there. So you can write it is approximately 5 electron volt. Okay, just approximation only, minus. And here you will find approximately, whenever you divide it by each one, it will be approximately 4 electron volt. Approximate. This is only approximation, because 423 divided by 2000, in 2500 you can consider 2500. If so, it will be 5. Similarly, 3250, it is 3. So approximately we are considered as like this. So we are getting approximately 1 electron volt as the energy. Okay, which energy? Kinetic energy. Okay, this kinetic energy we have to express in. Okay, in which unit means we have to express in. The given units are meter per second. So you are supposed to convert that electron volt into joule. So it will be 1.6 into 10 raised to minus 19 joules, because this is the 1 electron volt value. Now the kinetic energy value is replaced like this: 2 half mv square is equal to 1.6 into 10 raised to minus 19. Then v square is equal to 1.6 into 10 raised to minus 19 divided by m into 2. This is the concept which you are getting. This is your v square. So here 1.6, this is 3.2 into 10 raised to minus 19 divided by, see, there is mass. The mass of the electron is 9 into 10 raised to minus 31 kilogram. Okay, this could be the mass of the electron. So if you are simplifying this, see here, 3.2 divided by 9 into 10 raised to minus 19 into 10 raised to 31. Because this minus 31 went to numerator, always use the shortcuts. Now this is equal to, it is equal to 10 raised to, if it is 20, it will be 11. So it will 10 raised to 12. Okay, so 10 raised to 12. So, and this value will be, it is 3.2 by 9. 3.2 by 9 will be less than 1 value. So 3 by, okay, it is approximately 0.3. Okay, 0.3. Okay, it will be the value. So this is the concept, 0.36. Let us consider 0.36 into 10 raised to 12. So this value, okay, you are getting this as the answer to this one. Now this v square, so that what is v? That is equal to root of, okay, root of 10 raised to approximately 10 raised to 0.36 into 10 raised to 12. Okay, 0.36 into 10 raised to 12. So it can be written as 36 into 10 raised to 10. 36 into 10 raised to 10. So this is equal to 6 into 10 raised to 5. So your answer will be 6 by 10 raised to 5. So the right option to the question number 2 will be option A. So that's the answer to the question number 2. Now let us move to the next question, question number 3. So in this question, what they have given, a certain metallic surface is illuminated with a monochromatic light of wavelength lambda. The stopping potential for photoelectric current for this is 3V0. If the same surface is illuminated with the light of wavelength 2 lambda, the stopping potential is V0. The threshold wavelength for this surface for photoelectric effect. So they were asking us once again the threshold wavelength. Since you know that what is threshold wavelength from the previous question, now we will discuss something about this stopping potential. From the photoelectric experiment that you have learned that particular word and what is there. Since when a photon of certain frequency that makes possible the ejection of electron surface, you know that that electron is ejected. Since h nu is the photon energy, h nu 0 is the minimum energy requirement by the material, then whenever we compare these two values, the remaining amount will be the kinetic energy of this ejected electron. This ejected electron is drifted towards a positive terminal that we have placed here with some energy is known as kinetic energy. So this kinetic energy, how much it is? So what we are doing, we are going to reverse the potential of this positive terminal, which will help us to block the entire motion of the electrons that is ejected from the photoelectrode towards the anode. So that kinetic energy always equal to the potential energy, that means Q into V. So we can write in this case it is equal to E into V. This is the kinetic energy. From the concept, you know that this kinetic energy is equal to E into V0. That V0 is known as stopping potential. That means the negative anode potential that we have given to this plate anode, which equals to the kinetic energy of the ejected electron that is targeting the anode. So in that way, we have calculated the kinetic energy of the electron that ejected from the photosensitive material and drifted toward the positive terminal of the photoelectrical experimental setup. Now see here, this kinetic energy is EV0, then we know Einstein equation, that equation says K is equal to H nu minus H nu 0. This is your kinetic energy concept. Now you are rewriting this as EV0 is equal to Hc by lambda minus Hc by lambda 0. Once again, the same equation we are using. Now, what is the question? They were asking us the threshold wavelength for this surface for photoelectric effect. So they were asking the value of the lambda 0. So you are supposed to get the lambda 0 from the 2 points which I have given in the question. So in the first part of the question, what they have mentioned there, see the wavelength of the photon, that incident is lambda. That time the stopping potential is 3V0. So what we will do here means we will write here 3EV0 is equal to Hc by lambda minus Hc by lambda 0. Fine. This is the first case that is given in the question. Now what they are doing, they have replaced the same surface is illuminated with the light of wavelength 2 lambda. That means lambda is replaced by 2 lambda, but you know it's same material, so lambda 0 won't change, it will remain as it is only. So that in the next case, you will write it is EV0 is equal to Hc by 2 lambda minus Hc by lambda 0. This is the second condition. See here, if this EV0 substituted in equation 1, what change it will bring? See here, 3 into Hc by 2 lambda minus Hc by lambda 0 is equal to Hc by lambda minus Hc by lambda 0. This is the condition which you are getting. Now see in the both side, in the RHS as well as in the LHS, HC term is common, it is cancelled. Okay, so you can do it later also. It's according to your knowledge level. So this is can be simplified. 3hc by 2 lambda minus 3hc by lambda 0 is equal to hc by lambda minus hc by lambda 0. This is the condition which you are getting after simplifying this. Now I'll write here, okay, what is there? 3hc by 2 lambda hc by lambda. So transposing 3hc by 2 lambda minus hc by lambda to LHS, and this minus 3hc by lambda 0 to RHS. So it will be plus 3hc by lambda 0, and there is already one hc by lambda 0 exist. So hc by lambda 0 is there already. Now see here, since the LCM you can take it as how much it is 2 lambda, then it will be 3hc minus 2hc divided by 2 lambda, and in the RHS you will find 3hc by lambda 0 minus hc by lambda 0 is equal to 2hc by lambda 0. So this HC I told you already in the beginning, you can cancel it in the beginning itself according to the your knowledge level. If not so, you can do it later also. Now see here, 3hc minus 2hc is hc. So it is hc by 2 lambda will remain here. Okay, hc by 2 lambda is equal to 2hc by lambda 0. hc cancelled. Now you are getting lambda 0 is equal to 4 lambda. This is the answer which you are getting. That means the answer to the question number 3 will be lambda 0 threshold wavelength is equal to 4 lambda. That is the answer to the question number 3. Please note it. So that's it about the question number 3. Now let us move to question number 4. The question number 4 says that an electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 by 10 raised to minus 2 nanometer, the potential difference is, the question is potential difference. Before entering into the calculation of potential difference, first of all should know what is a de Broglie wave. You know that de Broglie wave is the wave associated to a moving mass. It is also known as matter wave. So when a mass is moving, and you know, you must be heard also what is the rest mass of photon. Rest mass of photon is 0. What does it mean? Means what amount of mass remains when the particle moves in such a speed like 3 by 10 raised to 8 meter per second. So when a mass travels in such a speed, then the entire mass converted into energy, and that you will find there a waveform. So what is the rest mass of the photon? It becomes 0 because entire mass converted into energy. So that a moving mass having some reduction in the mass, that is reduced mass concept will be there. Because of that, see, reduced mass concept is between two masses. So I am not saying like that, I am saying like this, a moving mass will have some loss of mass is showing because according to the energy that they gained, according to the energy level that can maintain by the mass. 1 gram of substance can make this much energy. Suppose it is 10 joule, then 1 gram is always making 10 joule. But 1 gram mass is moving with some energy and some velocity, and it possesses some kinetic energy. When we calculate the kinetic energy and converting into mass, there we find some difference in the masses. So that reduction in the mass become wave. So that is the concept of the rest mass concept. See here, so that when a particle moves, that motion brings some a waveform around it. So that is known as de Broglie wave. So that what is a de Broglie wave? Simple way you can say it is a wave associated to a moving mass. So that wave forms from the reduction of the mass from the body. So now look here, de Broglie says that the wavelength associated to a moving mass is equal to lambda is equal to h by p. Lambda is equal to h by p, and you know kinetic energy is equal to p square by 2m. P square by 2m. Now this kinetic energy from the previous question, you have mentioned it as EV, so you will write it is EV. So it is P square by 2m. Now see what is P. P square is equal to 2mev. Now P is equal to root of 2mev. This is the answer which you are getting from this equation for the momentum. Now see here, this is the de Broglie concept. Lambda is equal to h by P. So on substituting this value here, lambda is equal to h by P is root 2mev. This is the concept. And you know these things are constants because who is moving here? Electron is moving. So you can use this formula for different particles. And there one thing I'm reminding you, you have to change the mass, you have to change the charge. If the particles entirely different, so this time it is electron. Suppose if you are considering those values of electron, that means H is not the value of electron, it is Planck's constant. It is 6.36. Okay, 6.6 into 10 raised to minus 34 divided by root of 2 into mass of electron is 9.1 into 10 raised to minus 31 into charge of electron is 1.6 into 10 raised to minus 19 into V. This is the concept which you are getting from this equation. So altogether, except this V. Okay, what I am doing here means I'll write here 6.6 into 10 raised to minus 34 divided by root of 2 into 9.1 into 10 raised to minus 31 into 1.6 into 10 raised to minus 19 into root V. This is the concept. Okay, altogether this value is equal to 12.27 by root V angstrom. This will be the answer to the wavelength which you are getting from this equation. So if you want, you can rewrite it in this form also, root of 150 by V angstrom. Okay, this is the answer which you will get once you use this de Broglie concept to calculate the potential or either the wavelength associated to a moving electron. Okay, now see here, since you know that the wavelength equation is lambda is equal to 12.27 divided by root V angstrom. Root V angstrom, you are supposed to convert that one into meter or nanometer, since the given wavelength in the question is lambda is given here, it is equal to 1.227. okay, 22 into 10 raised to minus 2 nanometer is given. Okay, so you can convert it into meter or you can convert it into angstrom according to yours. So they can 1 nanometer is equal to 10 raised to minus 9 meters. So I'll write here 1.22 into 10 raised to minus 2 into 10 raised to minus 9. Okay, this could be the concept in meter. So that this is equal to 1.22 into 10 raised to minus 11 meter. So your wavelength is 10 raised to minus 11. Similarly, look here in the RHS, angstrom is there. You can convert it into meter. 1 angstrom is equal to 10 raised to minus 10 meter. 10 raised to minus 10 meter. This is your 1 angstrom. Now the case is they were asking you the value of the V. So from this equation you are supposed to get the value of V because it is the voltage they were asking. So what I'll do here means I'll just do like this. Here lambda is equal to root of 150 by V is written, that is equal to in angstrom. Then I'm going to square both sides. So see here, it is equal to this angstrom should be replaced into meter. So that should be into 10 raised to minus 10 meter. Okay, this is the wavelength result which you are getting. On squaring both sides, what you will get? Lambda square is equal to 150 by V into 10 raised to minus 20. This is your concept. Now, how much is V? V is equal to 150 into 10 raised to minus 20 meter divided by lambda square. Okay, since you have already made the conversion of wavelength into meter, you can just substitute here 150 into 10 raised to minus 20 divided by lambda square means 1.22 into 1.22 into, and here it is 10 raised to minus 22. This will be the concept. Now look here, it is 150 divided by 1.22 into 1.22 into this 10 raised to minus 22 will go to the numerator, will be plus 22, then it will be 10 raised to 2. Okay, now look here, this value. So approximately this value 150 divided by 1.22. So this value, suppose if you are, okay, rewriting is 1.22 into 1. So it is 12 into 12 is equal to 144. 12 into 12 is equal to 144 means approximately this is equal to 100. So if so, you can write 10 raised to 2 into 10 raised to 2 is equal to 10 raised to 4 volt. That means the voltage become 10 raised to 4 volt. So that is the answer to this question number 4. What is the potential difference? The potential difference by this motion of the charged particle give rise a range 10 raised to 4, and that's it about the question number 4. Now let us move to question number 5. The question number, what is there? An electron of mass m and a photon have same energy E. The ratio of de Broglie wavelength associated with them is. What is the ratio of the de Broglie wavelength associated with them? See here, one of the particle is electron, other one is photon. So these are entirely different concept. So that from the previous question, that means fourth question, you must be aware about the kinetic energy or energy of the electron. See here, since you know that lambda is equal to h by p. Lambda is equal to h by p, which is equal to, where you know p square by 2m is equal to k. This k is known as the energy, so that it can be replaced as is equal to E. So what I'll do here means I'll write here P square is equal to 2 into M into E. This is the concept, 2ME. P square is equal to 2 into M into E. 2 into M into E. This is your P square value. Then P is equal to root of 2ME. So this is the equation which you are getting for the momentum in case. Now let us rewrite it as lambda of electron. One of the particles electron, lambda of electron is equal to h by root 2 ME. This is the equation which you are getting as the wavelength of the electron. Now let's see, if the other particle is photon, then photon energy E is equal to hc by lambda of photon. I'll write P. Now what is lambda P? Lambda P is equal to hc by E. This is your second equation. This is the concept for the photon. Now they were asking us the ratio. Since the first particle mentioned the question is electron, you are supposed to take the ratio of lambda E by lambda P. So if you are taking the ratio of lambda E by lambda P, lambda E by lambda P is equal to lambda E is equal to h by root 2ME into lambda P is equal to E by hc. So this is the concept which you are getting. So h you can cancel, and what will remain here? 1 by c into E by root 2ME is the answer which you are getting. Now just some kind of adjustments in this equation will help you to get into the answer easily. See here, what I am doing means I am going to make the square root common to the numerator also. If so, then it will be 1 by c into whole root of this E will be E square divided by 2ME. See here, root of E square is E. It is not E square divided by 2ME. Okay. So when it is, okay, root is taken, then E square will be E. So your answer E cancelled. You will get it is 1 by C into root of E by 2m. This is the answer you are getting. Now you can rewrite. Okay, according to the given question, therefore, lambda E by lambda P is equal to 1 by C into root can be replaced as E by 2m whole raised to 1 by 2. So, this will be the answer to the question number 5. So, what is which is the choice? Just have a look. 1 by C into E by 2m whole raised to 1 by 2. So, option D will be the right answer to the question number 5. So, that's it about the question number 5. Now, let us move to question number 6. Question number 6. An alpha particle and a proton are accelerated from rust by a potential difference of 200 volt. After this, their de Broglie wavelength are lambda alpha and lambda proton respectively. The ratio of lambda p by lambda alpha is the question. Since you are familiar with the de Broglie hypothesis and the equations which I have mentioned you, then use that equation directly. Let's see how we can do. See here, one of the particle is the alpha particle. Alpha particle means that is equivalent to a helium nucleus. Alpha equivalent to a helium nucleus. That means charge is 2 proton, mass is equal to 4 proton. Okay. Now, proton means it's a positively charged particle which is there inside the nucleus. So, one of the particle is the proton and another particle is the alpha. So, whenever we compare the mass of proton as 1, then mass of alpha is equal to 4. Charge of proton as 1, then charge of alpha is 2. Okay, this one should be noticed in this equation. Okay, this is the concept. Mass of alpha is 4 times of mass of the proton. Charge of alpha is 2 times of the charge of the proton. In that way we can. Now see here, the equation is lambda is equal to h by p, and this p we have written k is equal to p square by 2m, then k replaced by ev is equal to p square by 2m, then p square is equal to 2m ev, then p is equal to root 2m ev. This is your concept of the momentum. That you can substitute here, lambda is equal to h by root 2m ev. This is the standard equation. Now, what you will do here means you are supposed to derive, or you are supposed to rewrite this equation for one for the proton, another one for the alpha. So, how will rewrite? So, I will write like this: lambda alpha is equal to first particle, I think it is alpha. Lambda alpha is equal to h divided by root 2 into m alpha e alpha v. Okay. This is the first condition which you are getting. Similarly, for lambda of proton is equal to h by root 2 into m mass proton charge proton v, because both are accelerated from the rust by a potential difference of 200. That voltage remains as it is. So, in both circumstances, the V remains as it is. Now, see here, they were asking us the ratio of lambda P by lambda alpha, they were asking. So, lambda P by lambda alpha is equal to, see, lambda P is h by root 2 m P E P and V into alpha is whole divided by h will be here root 2 m alpha e alpha v. So, now you have the shortcut here. Most of the terms in this part will be cancelled, and finally what we are getting here means we will get root of m alpha e alpha divided by m proton e proton. Okay, this was you are getting from this relation. So, you can substitute there. It is equal to root of m alpha is 4, e alpha is 2 divided by m proton is 1, E proton is also 1. So you are getting it as root 8. Okay. Your answer is root 8. So root 8 is equal to 2 root 2. Okay, root 8 is equal to 2 root 2. So approximately it is equal to 2.8. Let us mark it as 2.8. Okay, because root 2 is 1.4. 1.4. 2 into 1.4 is equal to, approximately you can write 2 into 1.4 is equal to 2.8. So this is the answer which you are getting. So the answer to the question number 6 will be option B. So I am reminding you to be aware about all those things which I have mentioned here. Okay, because sometimes you may be in hurry, will forget to take the charge as E alpha and E proton. That may bring, suppose if you are not taking charge of the alpha as E alpha and it is substituted there as 1, usually you will get root 4 will be the answer. If so happen, then answer will be 2, you will not find. So there you are to, okay, you will be get confused. So this is the case which you have noticed. Sometimes they may replace this particle by some other particles. So every time whenever they have given different particles, you are supposed to get its charge and mass in this equation directly. So you can use it shortcut because no need to follow the entire steps. This is just elaboration of the idea, but you can use the end session idea, okay, in practice to do the objective type questions. Okay, now let us move to the question number 7. So let's see what is there in the question number 7. If a semiconductor photodiode can detect a photon with a maximum wavelength of 400 nanometer, then its band gap energy is. So see here, the maximum wavelength that can be detected by this semiconductor photodiode is 400 nanometer. That means that material is sensitive to those wavelength which is given in this. So what is the band gap energy? Suppose if you are changing the wavelength in different manner, then it may be that system may not be able to send electrons out, or system may not be able to produce more electrons for the conduction. So that since they have given the wavelength in nanometer, as per our discussion, I told you already, if they have giving a wavelength in nanometer, you can use one shortcut and that shortcut will help you to get the value easily. See here, the band gap energy. Band gap energy is equal to work function. Band gap energy is equal to work function, which is equal to hc by lambda 0. Okay, this is your work function value. Since you know that lambda 0 is the threshold wavelength as given, just convert it into energy. You will find, since it is given in nanometer, you can use the concept 1242 divided by the value is 400 nanometer. So you will get answer in electron volt. Suppose if it is given, it will be 3.15 electron volt will be the answer to this question. See here, this is the band gap energy which can be, okay, see the work function value says this much energy is there with that photon. That means to cross the or to then calculate the band gap energy, so you are, okay, photon is detected and this much energy is there in the photon and the material is sensible to this photon, means this much energy will be the minimum energy in that system. So that the band gap energy will be 3.15 electron volt. So that we can write like here, it is equal to 3.1 electron volt from the choices. That means the answer to the question number 7 will be option D, it is 3.1 electron volts. So that's it about the question number 7. Now let us move to question number 1, that is from atom and nuclei. Since you know that atoms are the smallest particle, smallest form or smallest stage of an element. Nuclei is its center. And most of the nucleons are there inside the nucleus, and you know that most of the atom models are briefing about the nature or the nucleus size and so many things, okay, you will find. And now you know that inside the nucleus the two particles are protons and the neutrons, and also around the nucleus you will find a charged particle, that is electron. They are revolving in certain fixed orbits. And lot of atom models you must be learned also. Thomson plum pudding model is there, Rutherford model is there, Bohr model is there. Almost all in all these models, we found that most of all these models are unable to explain the spectral emission. So they are modeling atom according to the emission of the spectra. So see here, the first question is a radioactive nucleus, that is ZXA, undergoes spontaneous decay in sequence. ZXA turns to Z minus 1b, Z minus 3c, Z minus 2d, where Z is the atomic number of element X. The possible decay particles in the sequence are possible decay particles. See here, before getting into the question and answer, before you know what are the three types of decays. Since a nucleus consists of, there are two kinds of nucleus. Okay, so one of the nucleus is having 6 proton, 5 neutron. Another nucleus is having 6 proton, 8 neutron. These are the two circumstances that we can consider in this topic. See, there is a nuclear instability. Here more protons, here more neutrons. Both will give some kind of nuclear instability to the nucleus. See, here proton number is more, neutron number is less. Even if their numbers are equal, most of the stable nucleuses you can cross check, you will find if it is oxygen, O8, 16. See what is there inside its nucleus. There are 8 protons and there are 8 neutrons. So it's a stable nucleus. So that whenever you know the configuration of nucleons inside the nucleus in that way, see these two nucleuses are unstable, because here more protons are there, here more neutrons are there. So that this nucleus wants to be a stable one, so that it wants to reduce the proton number. So it will capture electron. Okay, a electron capture you will find there. So this electron capture, when electron captured, then what happens? Proton combines with proton combined P plus E become a neutron. Okay. Now here more neutrons are there. This time it will eject electrons. Now where is electron inside? A neutron will decompose into proton and electron. Into proton and electron. Okay. This electron is ejected. Proton number will increase. That means proton number less, neutron number is more, then they want to reduce the neutron number so that they will increase the proton. They want to increase the proton number. See here, 8 neutron is there. The nucleus wants to make the proton number also 8. If the nucleus wants to make proton number 8, it has to, which one? Send some electrons from there. So this is the concept. This is known as beta minus decay. This is known as beta plus decay. Okay. So suppose if it is say nucleus, see, let us write the concept. X, the proton number is 6, total number is 11. In beta plus decay, what happened? Proton number decreases. That means it become 6 minus 1 Y. Okay, proton number decreases. See here, proton, one electron captured, electron with the proton become neutron, and now see proton decreased, neutron number increased, so its mass remains as it is. See, that means atomic number decreased by 1 in which emission? Beta plus emission. Okay, it is not there in the NCERT in the proper way, so that be aware about this beta plus decay. Now in beta minus decay, what happened? Let us write the concept. It is X6 14. Okay, X6 14. In beta minus decay, what happened? One neutron decomposes, electron left, proton remains. That means 6 become 6 plus 1, and the numerator index, upper index will remain as it is. That means no change in the total mass, but atomic number increased by 1. That means whenever you find due to a beta emission, atomic number is increased by 1, that is beta minus decay. And the same time, in a beta emission, you are observing atomic number is decreased by 1, that is beta plus emission. So, be aware about this kind of the emission. Now, another one is alpha. If a nucleus 6 proton, 8 neutron, okay, this nucleus can decay by sending alpha rays also. When a alpha ray sends out, then you will observe a mass equivalent to helium nucleus is getting reduced from there. That means if you are writing it as 6x14 in alpha decay, you are observing 6 minus 2 y 14 minus 4 plus 2 He4. Okay, this is the concept. That means atomic number decreased by 2, mass number decreased by 4. How? See here, 2He4 means it consists of 2 proton and 2 neutron. Okay, so that 2 protons went, 2 neutrons also went. That means atomic number decreased by 2, mass number decreased by 4. This is the alpha emission. Okay, so in beta emission, what happened? In beta plus emission, what happened? And now you know what is there in the alpha emission. Now see, let us come to the question now. The radioactive nucleus ZXA undergoes a spontaneous decay in the sequence ZXA. Okay, it becomes Z minus 1. Atomic number is decreased by 1. Atomic number is decreased by 1 means what kind of decay is that one? Just think of atomic number is decreased by 1 means it will be beta plus decay. Okay, so it is decreased by 1. Okay, usually in beta minus decay, it should be increased. So this decreased you are observing. So it is known as beta plus decay. Okay, now what happened? Z. So I'll write here ZXA become Z minus 1B. Okay, that means in between what happened? Beta plus decay. Okay, now it become Z minus 3Z, atomic number decreased by 2 again. That means it will be alpha decay. Now it becomes Z minus 2. That means Z turns to Z minus 2. That means atomic number increased by 1. Z minus 3 becomes Z minus 3 becomes Z minus 2 means increased by 1. That means it is known as beta minus decay. Okay, so what kind of decay? The possible decay of particles in the sequence are beta plus, alpha and beta minus. So the right option to the question number 1 will be option D. So you can choose the right option is option D. Now let us move to question number 2. A radioisotope X with a half-life 1.4 by 10 raised to 9 years decays to Y, which is stable. A sample of the rock from a cave was found to contain X and Y in the ratio 1:7. The age of the rock is, age of the rock they were asking. You know about the carbon dating. What is carbon dating? We are using carbon 14 radioactive element for the fossil learning process. That means if you want to know something of the age of the fossils, okay, so there we are using this kind of the substances. Now see here, a radioisotope with half-life 1.49 years. So the half-life means the time taken by a radioactive element to become its half of its initial mass. So 1 gram of x gram of substance become x by 2 gram. This duration is known as half-life. X by 2 become x by 4, known as another half-life. X by 4 become x by 8 is known as another half-life. See here, every time what amount remains, then the time taken by the substance to be reduced from that particular amount to the next half will be the half-life duration. So that when a substance of some gram become 1/8 of its initial mass, then how many half-lives crossed? See, there are 3 half-lives it crossed to become 1/8 of its initial mass. Okay, so this is the one of the simplest route to identify the questions like this without any formula. Now look here, half-life is for 1.4 into 10⁹ years. Now you have taken a rock or something from the cave. In that particular rock, initially it was full of that X isotope. Now what you are observing, one part of that isotope, okay, one part of the rock is that particular isotope, rest 7 part is the other one. That means what is the fraction of the isotope remain in that rock? It is 1/8 of the initial. That means this is the concept, 1/8 of the initial. To become 1/8 of the initial, how many half-lives it has to cross? So it is very simple to convey the idea. It has to cross 3 half-lives. So that, see here, 1:7 is the rock, means the isotope amount. Isotope become 1/8 of it, and the new substance is equal to 7/8. So our concern is this one. Isotope become 1/8 of its initial. If wants to become 1/8, it has to cross 3 half-lives. Therefore, the time, the age of the rock, age of the rock is equal to 3 into T half. 3 into T half. So what is 3 T half? 3 into T half is given 1.4 into 10⁹. So it is equal to 4.2 into 10⁹. Okay, so this will be your answer. Answer is 4.2 into 10⁹ years. So this is the age of the rock that you have taken from this cave. Okay, now, so that's the answer to the question number 2. Option C is the right answer to the question number 2. Now question number 3. In a reaction 92U234 become 88Y218, the number of alpha and beta particles emitted respectively. So this question we can answer in 2 manner. One, by counting the number of alpha beta emission randomly, or by formula. So that's the concept. Okay, so that, see here, in this reaction it is 92U234 turns to, so 88Y218. Okay, this is the concept. So I will write a simple formula here. Suppose your element is a, let us write ZXA. It turns to Z1YA1 by emitting N1 alpha and N2 beta. Okay, N2 beta. This is beta minus decay I am saying. N2 beta. Okay. This is the relation. From here we are going to create a new, frame a new equation. See here, A1 4. So I'll write here A is equal to A1 plus 4N1. 4 into N1. So that A minus A1 divided by 4 is equal to N1. What is N1? N1 is the number of alpha particles emitted. So it's very simple. Okay. Now see here, second one. There are N2 beta particles emitted. So how will write? Z is equal to Z1 plus 2 into N1 minus 1 into, that is also plus actually 2 into N1. Here minus 1 into N2 is minus N2. You are supposed to get the value of N2. So N2 will be, N2 is equal to Z1 minus Z plus 2N1. So your condition is Z1 minus Z plus 2 into N1 is A minus A1 by 4. So we got another equation, Z1 minus Z plus A minus A1 by 4. Okay. So this is the equation to calculate the number of beta particles that it emitted from this process. Okay. So I'll write this in the next page. Number of alpha particles is equal to A minus A1 by 4. Okay. A minus A1 by 4. Now that is of the N2As. N2As. We got it is Z1 minus Z. Z1 minus Z plus A minus A1 by 2. So this is the equation that we got it. Okay. Here 2 into 4 cancel is become 2. Okay. 2. So this is the answer which we got here. Now see here from this equation, N1, number of alpha particles you are supposed to get. So N1, N alpha is equal to, look there in the equation. What is A? A is the, okay, in the general form, it is ZXA. Okay, the superscript of the symbol is the atomic mass. So A is 234. A is 234 minus A1 is 218 divided by 4. Okay. So it will be 220 minus 34 is 14, it will be 16. So you can write 16 by 4. So your answer is 4. So how many alphas? 4 alphas. Now number of betas. So you can write here Z1 minus Z. Z1 is 218. Okay, Z1 is 218. So it is Z1 minus Z. 218 minus Z is 234. Okay, plus what is here? A minus A1. A is, okay, Z1 is not 234. Z1 value is the lower index value. So it is 88 minus 92 plus 88 minus 92 plus A minus A1. A is atomic number, that is 234 minus 218 divided by 2. Okay. So this is 88 minus 92 is minus 4 plus 234 minus 218 is 16 by 2. So this is equal to minus 4 plus 8. So your answer will be 4. So number of alpha particles emitted is 4. Number of beta particles also emitted is 4. So the right answer to the question number 3 will be 4 and 4. So this is the formula that you can use to solve this question. Huh? Hi all. Actually, I forgot to mention that break. Okay, anyhow, we will continue with our session. So, the last question that we had discussed is question number 3, and there we have calculated the number of alpha particles and beta particles emitted in that particular reaction. Now, let us move to question number 4. The energy equivalent to a 0.5 gram of a substance. It's a simple question. For basically it is a previous year entrance question as less common to board level examination. See here, energy equivalent to 0.5 gram of substance. Then you know theory of relativity. According to that, we know this energy is equal to delta m c square. You must be aware about this equation. So that this mass is 5 gram, that is approximately this 0.5 gram is given. So 0.5 gram into C is 3 by 10 raised to 8 meter per second whole square. Okay. Now this 0.5 gram, it is in gram. Since the speed of the light you have taken in meter per second, you have to convert that gram into kilogram. And you know 1000 gram is equal to 1 kilogram. So that 1 gram is equal to 10 raised to minus 3 kilogram. Okay, so 1 gram is equal to 10 raised to minus 3. 1000 gram is equal to 1 gram, then 1 gram is raised to minus 3 kilogram. So that you can convert this one into 0.5 into 10 raised to minus 3 kilogram. 0.5 into 10 raised to minus 3 kilogram into 9 into 10 raised to 16. Okay, because when we take the square of 3 by 10 raised to 8 is 9 and 10 is 16. And now look here, 0.5 can be replaced as 5. Okay, then you know if this 5, then it will be 10 raised to minus 4 into 9 into 10 raised to 60. So it is 45 into 10 raised to 12. Okay, so 45 into 10 raised to 12 you are getting. So you can rewrite as 4.5 into 10 raised to 13 joules. So this is the energy equivalent to 0.5 gram of the substance. So that's the answer to the question number 4, option D. Okay, now let us move to question number 5. The binding energy per nucleon for tin 5120, where mass of proton is given there 1.0078 U and mass of neutron is given there 1.00867 U and mass of tin nucleus is given there 119.902199 U. So you are supposed to get the value of the binding energy per nucleon. So the total number of nucleons in this tin is 120 because it is mentioned there. 50 SN 120. So the number of nucleons in tin is 120. You are supposed to get the value of binding energy per nucleon. That is a given question. See here, what is binding energy? First of all, we should know what is binding energy. Usually it's a question. Since you know that inside the nucleus there are positively charged protons and non-charged neutrons. A nucleus is arranged in such a manner where some energy is involved in the formation, because if the nucleus consists more than one proton, you know there will be electrostatic repulsion. Okay, so because of the electrostatic repulsion, they will move further, will away from each other. It's not happening here. That means some kind of force involved in that one not to do so. That means that force is known as nuclear force. So the energy that is utilized there to bind all these nucleons in a particular point is known as binding energy. So that binding energy, how we will calculate? The concept of the binding energy is delta m c square. This delta m is known as mass defect. Mass defect. So what is mass defect? Mass defect means it is equal to, there are how many nucleons, just have a look. 50 protons are there. Similarly, in this nucleus, suppose you are writing 50 protons are there, 70 neutrons are there. Okay. So, mass defect we are calculating like this. 50 into mass of proton plus 70 into mass of neutron minus mass of nucleus. That means M of T nucleus. Okay. This is the concept. So, this difference will let you to calculate the mass defect. So that it's given mass of proton is 1.00782. So, mass of proton is 1.00789 U. U is atomic mass unit. We have two methods here. One, this is the direct method, okay, usual method. Second is the shortcut. If you know 1 U is how much, then convert that 1 U into energy and express it in electron volt. And you know that 1 U is equal to 1 AMU, which is equal to 931 MeV. That means if you are able to get the mass defect in U unit, then just multiply it with 931. That is another alternative. Otherwise, you can get the mass defect. So, here see, already it is given in atomic mass unit. So, you will get the answer in units only, U only. So, your work is simple because just multiply it with 930 because 1 U is 931 AMU, 1 MeV, million electron volt. Then 2 AMU will be 2 into 931 million electron volt. It's like that only. Now see here, there are how many protons? Since it is the mass of proton, there are 50 protons. So into 50. Okay. So this will be the concept into 50. Suppose if you are multiplying it with 5. Okay. 5. So how much it will be? See here. 9 into 5 are 45, 4, 5 into 8 are 40, okay, 4, okay, then 5 into 7 are 35, 9, 3, 3, 0, 5. So, it is approximately into 10 because we are taken 5 only. So, it is 50.3944 approximately U. This is your total mass of proton. Okay, so let us mark it as ZMP. Okay, because usually this one we are using that particular condition ZMP. So your concept is it is ZMP. Now let us see. Okay, your mass of ZMP is equal to, I'll write it here because some kind of disturbance, 50.39. I'll make it as 4 U for your convenience. Okay, then this second. Now, what is the mass of neutron? So, neutron number is 70. So, you know 1 neutron is equal to 1.00867 U is neutron into it is 70. So, I'll make it as 7. Okay. So, if so happened, then see here 7 into 7 are 49, remaining 4, 7 into 30 42, that means 7 7 are 49, 4, 7 into 30 42, 6, 4 is there, 7 into 8 are, so it is 0, will be 5, 0 is 5, 0, 7, that means into 10, approximately 70.5069 U. So, it is equal to 70.5 U. This is the total mass of the neutrons. Now, what is total mass of nucleon? Total mass of nucleon is equal to, we have got one as 50.4 plus 70.5, we got 90, it is coming 120.9. So, this is your total mass of the nucleons inside the nucleus, 120.9. So, it is 121. So, I will make it as 121. So, total mass is equal to 121 U. Okay, this is the answer which you are getting, that is a nucleon mass. Now, mass of nucleus. Mass of nucleus is equal to, it's given there, that is equal to 119.90219. Usually, the significant figure that you have to consider all the time if you are doing this question at the time of entrance examination. For time being, you are just adjusting with these values, because what I'll do here means I'll make it as 120 U. Fine. This will become 120 U. Therefore, delta M is equal to 121 U minus 120 U is equal to 1 U. So, this is equal to 931 MeV that we have calculated. Because we know already one atomic mass unit is equal to 931 U, because one atomic mass means mass is 1 by 12 that of carbon atom. That is 1.66 into 10 raised to minus 27 kilogram. This mass you can substitute in this equation, convert it into electron volt, you will get this answer. Okay, that is a 1 U, and this is the 1 by 12th of carbon 12, which one mass, atom mass. So 931 MeV is 1 U. But what they were asking binding energy per nucleon, they were asking. Therefore, binding energy per nucleon is equal to 931 divided by nucleon number is 120. 120. So, approximately, see, if it is 9 times, is it 8 times 120? Okay, 120 into 8 means 96 will come. Okay, 8 times. So, that approximately 7 times we can consider. So, that the answer will be 7.5 MeV. So, the binding energy per nucleon will be 7.5 MeV. This is the method. Okay. So, if the mass is given in U unit only, you are supposed to do like this. If it is not given in U, it may be given in kilogram, you can convert that into U, then follow the same steps for both level examination. If it is either board level or entrance level, for all kinds of examination, you can use this same strategy. Okay, so that's the case of the question number 5. Now, it's quite interesting topic is ray optics. You know, it's one of the biggest topic which you are learning in the second year syllabus. And what the ray optics says, of course, you know, it says something about the nature of light, and it is considered light as a ray. So, what is a ray means, when a ray of light hits somewhere here, then it forms the shadow of this body behind. It is happening only if you are considering it as a ray. But in wave optics, what you have learned, if it is a wave, it will bend, that ray will bend, okay, through the edges of this obstacle. So, that is the concept of the difference between the ray optics and the wave optics. Okay. Anyhow, this is not our concern. We are going to learn what is there in the ray optics and what are those questions. So, the first question is, a plano-convex lens is made of material of refractive index 1.6. The radius of curvature of the curved surface is 60 centimeter. The focal length of the lens is the question. Okay. So, generally, we know that a plano-convex lens, this is the status of plano-convex lens. One side is plane, other side is convex. Okay. And now, the refractive index of this lens is, this material is 1.6, and the radius of curvature of this one is 60 centimeter. Okay, these are the values given. So they were asking us the focal length. So that there is a derivation which you know how to get the formula, lens maker's formula you must be learned. In that particular part you must be learn about how to derive. So for an example, so I'll consider here a single convex spherical surface. Okay, this is the principal axis. An object is placed which is framing an alpha angle. This one image you are observing here. So object is here, image is here, and now this is the center of curvature, and this is your angle of incidence. This is your angle of refraction. This is beta, this is gamma. Okay, so these are the few things which you can notice. And now see here, this is the point where you are supposed to take the measurement known as optic center. This optic center, and see here M, a small gap is there. To minimize that gap, you can reduce the aperture size. You can bring down. Okay, this point of incidence you can bring down, then definitely that will move toward this P side. Okay, anyhow, since it's a small gap there, you can take all the measurements still from P, not from M. Okay, so that concept. Now see, anything if you want to measure from the part of ray optics, you are supposed to use Snell's law. Snell's law. What Snell's law says, for a pair of media, ratio of sine angle of incidence to sine angle of refraction will be a constant. Okay, so that the ray is N1 and this is at N2. Okay, so for a pair of media, this is the sine I by sine R is equal to N1 by. See, whenever you reduce the aperture size, this alpha value will be reduced. If so, sine theta can be treated as theta. Then I is small, then R will be again small. That means sine I will be I, sine R will be R. So we'll write here like this: I by R is equal to N2 by N1. So now we can write N1 into I is equal to N2 into R. Okay, this is the condition which you are getting from this. Okay, anyhow, why I am making it so lengthy is no reason, because just to show that, because it is there as a derivation for your board level examination. So that derivation I am showing here, because for me it is nothing, it is just use a formula, substitute the values, then you will get the answer easily. Okay, that's it. Anyhow, I am just showing how to get such a result from here, that is known as lens maker's formula. Now I is alpha plus gamma. Alpha plus gamma. Exterior angle is equal to sum of two opposite interiors. So that I'll write here N1 into alpha plus gamma is equal to N2. Then R is gamma minus beta. Gamma minus beta. Because R plus beta is equal to gamma, then gamma minus beta is equal to R. So this is the answer which I get. So I'll write here N1 into alpha plus gamma, N2 into gamma minus beta. Okay. So here you can substitute for alpha, beta, gamma, because alpha means tan alpha. So how much it is? Alpha means tan alpha means that is equal to Mn divided by Om. Mn divided by Om. Okay, this is your alpha. Similarly, do for beta. That is also is equal to Mn divided by, in case of beta, it is Mi. Similarly, do for the gamma also. That is equal to tan gamma. That is equal to Mn divided by gamma value is Mc. Okay. See, all these values are mentioned there. So, alpha is Mn divided by Mo. Mn divided by M. These are the values that you can substitute. After substituting all these values, you will get an equation like this. 1 by F is equal to n minus 1 into 1 by r1 minus 1 by r2. This is known as lens maker's formula. Okay. Since you know that n1 value is 1, n2 value is n, it becomes n minus 1. If n1 value is not 1, n2 value is not so, then n2 by n1 should be written there. There is no issue in that. Now see here, they were asking us you the value. Since you know that lens maker's formula says that 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. It's a plano convex. Okay, then the radius of this part is infinite, this part is minus 60. Okay, this part is infinite, the plane surface have infinite radius, and the other one is minus 60 according to the sign convention. So you can substitute here, n become 1.5 minus 1 into 1 by infinite minus 1 by minus 60. Is it okay? So this is equal to 1 by 2 into, here it is 1 by 60. 1 by 2 into 1 by 60 will be the answer. So it will be 1 by 120. 1 by 120. So your answer is 1 by f is equal to 1 by 20 because 0.5 divided by 60. Okay, 0.5 means 1 by 2 into 1 by 60. So you are getting is equal to 120, then f is equal to 120. So here I took it as 1.5, okay, for the easy calculation. And now see the answer is 1 point, the refractive index of the material is not 1.5, it is 1.6 as given. So suppose if it is 1.6, what will be the condition? Suppose it is 1.6, then 1.6 minus 1 will be 0.6. Okay, 0.6 into 1 by 60. 0.6 into 1 by 60. How you can make it as? It is equal to 6 into 6 by, if you are make it as 6, then 6 by 600. Okay, so you can make it as 1 by 100. So you are getting 1 by f is equal to 1 by 100, f is equal to 100. So you will get the exact answer of the focal length. See, this is the concept. So that in some cases they can be cancelled very easily like this if no issue. But here if not so happened, I picked 1.5. So just compare those values. You are getting the answer of focal length as 100 centimeter for this combination, and that is the answer to the question number 1 from the ray optics. Okay. Now let us move to question number 2. The refractive index of water is 5 by 3. A light source is placed in water at a depth 4 meter. Then what must be the minimum radius of the disc placed on the water surface so that the light of source can be stopped? So refractive index is given there, and see here, if it is the concept, okay, here you are placing the source as light is stopped. Light is stopped. Okay, if so happened, this is the size of the disc. This could be the radius. Okay, and you know the refractive index of water is 4 by 3. Okay, so what they were asking, what must be the minimum radius of the disc placed on water surface so that light of source can be stopped? See, from here onwards, if the water is lowering, then you know in this edge of this, they will finding grazing emergence. Then afterwards, it will be returned, totally reflected. And now there is another concept, real depth divided by apparent depth is equal to refractive index. Okay, so that a light source is placed in water at a depth of 4 centimeters. So this is your 4 centimeter depth. Okay, this is your 4 centimeter depth. And if so, then this is a right angle triangle, you know, and there you will find the radius. Okay, so 4 square plus r square is equal to this value, and you know this angle will be critical angle. This will be critical angle. Why? Because the light is totally reflected into the same medium beyond this angle. That means grazing emergence, angle of incidence is theta c, angle of refraction will be 90 degrees. So it is critical angle. And you know critical angle Sin C is equal to 1 by n. Sin C is equal to 1 by n. So it is equal to 1 by n value is 5 by 3. Then sin C is equal to 3 by 5. 3 by 5. That means you know from this what is sin theta. Sin theta is equal to opposite side divided by hypotenuse. Hypotenuse. See here, this 3 by 5 says that it is opposite by hypotenuse. So if it is theta, this is alternate angles is also theta, then this will be 3. This will be 5. Then see if it is 3 and 5, just have a look. 5 square minus 3 square is equal to 16. Root of 6 is 4. Of course, that is right. So that we really easily we can give the answer to the question. The R value will be 3. So the answer to the question number 2 will be option A. Now let us move to question number 3. An equivalent convex lens is cut into two halves along x o x dash and y o y dash as shown in the figure. Let f dash and f double dash be the focal length of the complete lens in each half in case 1 and of each half in case 2 respectively. Then you are supposed to compare those values. See here, this is the lens that we cut along this line known as x o x dash. Okay. The focal length of the lens depends according to lens maker's formula n minus 1 into 1 by r1 minus 1 by r2. Just think of whether you are observing any kind of change in this. N is the material, is not changed. Even if you are cutting into number of pieces, that won't change. Since you are cutting like this, radius of curvature of this one is R2 and this is R1. Okay, that remains as it is. You can cut into number of pieces in this way. Okay, so see here, you can cut like this. Every piece will have same radius of curve because it belongs to that particular lens only. Okay, so we can say that whenever you cut like this along x o dash, you won't find anything. So a equiconvex is cut into two halves along x o dash and y o y dash as shown in the figure. Let f and f dash fw be the local length of complete lengths of each. So f dash will be the first case, so that you will find f is equal to f dash if you are cutting along x o x dash. Now see here, the second case is you are cutting like this. If so happen you are getting two lenses of this kind. Okay. Now see here, this radius is R1 and this radius is infinite. And this radius is infinite, this radius is R1. See, one of the radius become infinite. So if so, then we can write for the plano 1 by f is equal to n minus 1 into, okay, we can write 1 by r minus 1 by infinite. So it is equal to n minus 1 by r. N minus 1 by r. And what is here? Here see, this is, okay, this is r1 is positive, r2 is negative. So we can write here 1 minus 1 into 1 by r minus 1 by r according to convention. So we got it. How much? 1 by r minus 1 by r is 2 by r. Okay, 1 because it become plus here. So 2 by r. So it will get, you will get n minus 1 into 2 by r. So your answer is 2 into n minus 1 by r is your answer. So the lens for the given lens, that is your f. Okay, and that f remains as f for the first portion. Now look here, it is become n minus 1 by r. That means if this 2n minus 1 by r is f, then this will be f by 2. So what is this? This is your f double dash. So f double dash is f by 2. Okay, f dash is which one? F. So we are getting. So you can write f double dash is equal to f by 2. F double dash is equal to f by 2, or f is equal to which one? F double dash is equal to 2 times of f, then that way you can consider. So the right option is f dash is equal to f, f double dash is equal to 2f. So right option to the question number 3 will be option C. That is the right option to the question number 3, option C, because f dash is equal to f, f double dash is equal to 2f. So this is the answer which you are getting for the question number 3. Now let us move to question number 4. The refractive index of the material of a prism is √2 and its refracting angle is 30 degree. One of the refracting surface of the prism is made a mirror inwards. A beam of monochromatic light entering the prism from the other face will retrace its path after reflection from the mirrored surface. If it is angle of incidence on the prism is, അപ്പോൾ ചോദ്യം, in this question what we understood means a prism where one part is made as mirror. So one of the ray is approaching and you know that it has to retrace. If it wants to retrace, then the ray should incident on that surface normally. Okay, then only that ray will retrace. If you are constructing this normal, then this could be the angle of incidence. They were asking, if so happened inside, what should be the value of this one? So this can be R1. Okay. So you are supposed to get the value because refractive index of the material prism is √2 and its refracting angle is 30 degree. That means refracting angle means 30 degree. This is 30. Okay, and it is not angle of refraction, it is refracting angle, it's 30 degree, that means prism angle is given there. Now see here, according to the concept, you know that angle of prism, okay, if A is the angle of prism is equal to R1 plus R2. Okay, here R1 is, okay, not known, R2 is 0. Because R2 will frame here, it is 0 because normal incidence and retracing the path, so that R2 is 0. That means you got R1 is equal to 30. So angle of refraction from the first surface is equal to 30 degree. Now what they were given? They have given the refractive index of the material. Now according to the law, sin I by sin R is equal to N. Okay. So N is √2. So we can write sin I is equal to √2 into sin 30. √2 into sin 30 because R is you got as 30. Sin 30 is 1 by 2. So you will get it as 1 by √2. So your angle sin I is 1 by √2. Then I is equal to sin inverse 1 by √2 is equal to 45 degree. So this could be happened only at when the prism angle of incidence is made as 45 degree. So you are getting answer to the question number 4 as 45, and that's the answer to the question number 4. Now let us move to question number 5. A microscope is focused on a mark on a piece of paper and then a slab of glass of thickness 3 centimeter and a refractive index 1.5 is placed over the mark. How should the microscope be moved to get the mark in focus again? So let us imagine this is the microscope lens. This is your spot and that adjustment is made X. Okay. Now this X that should be managed because this is the focal point. Suppose if anything brought the position of the O up or down, that amount of length should be shifted in the position of the microscope. Hope you understood what I mean. Means this is always, that should be x. It will not change because this is the focal point. Suppose whenever you place a glass block having thickness, how much? It's given there 3 centimeter. Then you know the refractive index is 1.5 given. Now the point is belongs into the glass and you are there still in air. So object is in glass and you are there in air. That means this glass will bring a shift in the actual position. Get that shift, how much it is, that much it has to move. Because this O point will be somewhere here. Whenever you watch this time, that means a shift is produced. So you'll use a concept. Real depth divided by apparent depth is equal to refractive index. Okay. So real depth is 3 centimeter. 3 centimeter divided by apparent depth is equal to refractive index is coming 1.5. Then apparent depth is equal to 3 centimeter divided by 1.5 is equal to 2 centimeter. Okay, this is your apparent depth. If your apparent depth is 2 centimeter, then shift produced is equal to real depth minus apparent depth. Real depth is 3, apparent depth is 2, so your shift is 1 centimeter. That means this point is raised by 1 centimeter up. That means this microscope should be lifted up by 1 centimeter. So that's the answer to the question number 5. Okay, and the right option is option A. So that's the concept. Okay, be aware about all those things. Now, let us move to question number 6. A biconvex lens has a radius of curvature of magnitude 20 centimeter. Which one of the following options describe the best the image formed of an object of height 2 centimeter placed 30 centimeter from the lens? So it's a biconvex lens. This is biconvex lens. Okay. And it is mentioned there the radius of curvature. The radius of curvature of magnitude 20 centimeter is given. That means it's a biconvex lens. Radius of curvature is given as 20 centimeter. So Oh, slight disturbance. Anyhow, a biconvex lens is given here. This biconvex lens, this is the structure of biconvex lens. And see here, the radius of curvature is given as 20. R is equal to 20. Okay. Now, an object is placed, okay, an object is placed in front of it at 30 centimeter. That means if it is the object having size 2 centimeter, then it is approximately 30 centimeter from the lens. And for your identification, easy identification, they have given the magnitude of the radius of curvature. You know, focal length will be the half of the radius of curvature generally. That means if 20 is the radius of curvature, the focal length will be 10. That means this will be which one? Beyond the center of curvature. Object position is beyond the center of curvature. So usually that image will be between the focal length and radius of curvature. That means what is the focal length means? It will be 10. So if it is focal length means it will be 10 centimeter, and this will be the center, that is equal to 20 centimeters. So you can, this is a concept. That means object is placed beyond the center of curvature, the image will be on the other side inverted. It will be inverted because beyond the center of curvature is inverted always. Okay, it will be real also because the rays, see, this is the concept of the concept, this is the focal on the side, and whenever you construct, this will intersect here. Okay, that means the rays are actually converging to this point, so that this is a real image. Okay, so if the rays are actual convergence showing, and you know on the other side also there is C. Okay, and this image will be between F and C. So how much it will be? See here, F will be 10, C will be 20, then it will be between 10 and 20. That means it will be between 10 and 20 means it can be 15, it can be anything. Okay, similarly, if size of the object is 2 centimeter, then this will be less than that. So here there are, okay, choices you can choose. One, the image is real. Second, it is inverted. The real inverted image less than the size of the object, that has to be taken. So real, inverted, and height is 1 centimeter is an option. Real, inverted, and height is 4 centimeters. See here, this won't be greater than this one because object is at 30, image is between 10 and 20. So it is somewhere closer. So that image will be smaller compared to the object. So anyhow, if you want to calculate by numerically, you are supposed to get the value of the V. See here, 1 by F is equal to 1 by V minus 1 by U. This is one of the method. And here V you are supposed to calculate 1 by V minus 30 because left. And the focal length is how much it is given? 10. Okay, 10. So here you get this positive focal length. So 1 by 10 minus 1 by 30 is equal to 1 by V. Okay, so you can simplify this. 30 minus 10 divided by, okay, 300 is equal to 1 by V. Then V is equal to 300 divided by 20. So you are getting, okay, 30 by 2 is equal to 15. See, this one I told you. Okay, this is your CB value. So it is equal to 15 centimeters. That means object is somewhere closer. Anyhow, the size of the image, height of the object divided by height of the image, or height of the image divided by height of the object ratio is known as the magnification. So that is transverse magnification. Then you can compare with your longitude, linear magnification will help you to get the values. Anyhow, it is very easy to say that the image will be real, it will be inverted, and anyhow less than the size of the object actually. So in this there is only one option which we can choose as real, inverted, and less than the size, that is option C. So the right answer to the question number 6 will be option C. And see here, HI by HO is equal to V by U. That's the case for the magnification. That is your magnification. HI by HO is equal to V by U. HI is the height of the image that we have to calculate. HI, okay, by 2 is equal to V is 15. Okay, V is plus 15 and U is minus 30. Okay, U is minus 30. And now look here, this will be 1 by 2. So HI is equal to, HI by 2 is equal to minus 1 by 2. Okay, now you can write hi is equal to 2 into minus 1 by 2 is equal to minus 1. So this is your height of the image. Okay, that means height of the image is 1 centimeter and negative sign says that it is real. Okay, and inverted. Okay, real and inverted. So this negative sign says that real. So this is the answer to the question number 6, option C. See, without doing this thing, we can go for an assumption. We can guess the value since by looking that particular thing, knowledge based on the ray diagram that you have learned in case of lens as well as in case of mirror. So be aware about all those things. So that's it about the question number 6. Now let us move to question number 7. If the focal length of the objective lens is increased, then magnifying power. Focal length of the objective lens. You know that there are two optical instruments. One is my compound microscope. Compound microscope. There are two lenses, one is known as objective, other one is known as eyepiece. Then there is telescope. There also you will find similar kind of lens arrangement. One is objective, other one is eyepiece. See, only in these two instruments you are finding the coaxial arrangement of the two lenses. So in this case, what is the magnification? So we'll write magnification is equal to L by FO into D by FE. This is your magnification. Similarly, in this case of telescope, it is equal to FO by FE. This is a general condition for the magnification for the telescope as well as for the microscope. So these derivations also be required for the board level examination. Anyhow, look at the question. The focal length of the objective lens is increased, then magnifying power off. See, if FO value you increased, magnifying power will decrease. If FO value you increased here, magnifying increase. That means in case of telescope, magnifying power increases, and in that case of microscope, it is decreases. Now let us choose the value. Microscope will increase, but that of telescope will decrease. No, it's wrong statement. Microscope and telescope both will increase, not at all. Microscope and telescope both will decrease. No. Microscope will decrease, but that of telescope will increase. That's right option. See here, microscope decreases and that of the telescope is increases. So this is the concept here. M increases when FO increases. Here M decreases when FO increases. This is the concept. Okay, so be aware about that particular question, question number 7. So option D is the right answer to question number 7. Now question number 8. An object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, then displacement of the image will be. See, it's a concave mirror. Okay, concave mirror. So this is the status of concave mirror, and you know that object is placed at a distance of 40 centimeter. Okay, 40 centimeter. Object is placed at 40 centimeter. This is your object. It is placed at 40 centimeter. See, 40 centimeter. So since it is given that focal length is 15 and this radius of curvature will be 30. Okay, and focal length will be 15. So this is 15. Okay. Now the question is, object is placed beyond the center of curvature that we got already. Okay, now where will be the image? You know, image will be between focus and the center of curvature. Okay, for the first case, object will be between focus and center of curvature that you will find. Now what you are doing, if the object is displayed through a distance of 20 cm towards, that means from the 10 it brought to okay, brought by some length. So it is from 40, it is 20 centimeter, you moved ahead. That means it is now at 20. That means it is here. In the second situation, this is your F, this is your C, object is here. Okay, and now where is image? See here, the image you will find somewhere here. That means beyond the center of curvature. Beyond the center of curvature means it will be more than 30. More than 30 means there are two things, 36 centimeter away from the mirror, 36 centimeter towards the mirror. So it is always away from the mirror. So we got the answer very easily. But this we can measure in terms. See, in this case, you know the mirror formula is 1 by F is equal to 1 by V minus plus 1 by U. This is your mirror formula. Since you know the focal length, since you know the object position, get the value of V. So you will get 1 by V is equal to 1 by F minus 1 by U. Focal length is negative, U is negative. So you can write like this, 1 by minus 15 minus 1 by minus 30, both are negative. So you will get minus 1 by 15 plus 1 by 30. LCM is 30. Okay, you can take 30. Then it will be minus 2 plus 1 by 30 is equal to minus 1 by 30. Okay, minus 1 by 30. Okay, so you are placing it is 2 minus 1. It is equal to minus 1 by 30. So 1 by V is equal to 1 by 30. V is equal to 30. This what we are getting here. Okay, if you are taking 30 as LCM. Okay, so 2 into 2 plus 1. Okay, minus 2 plus 1 is okay. It is you are getting 30. Okay, so V is equal to, you are getting it as 30 centimeter. So that's the concept about this one. Okay, if you are using the formula here. Likewise, you can do one thing. You are moving this one to, oh sorry, here the distance is, object distance is not 30. A slight mistake is there. So I'll rewrite it. It is not 30. I'll write here. It is 1 by minus 15 minus 1 by minus 40. Sorry, it is okay, mistaken. It's 30. Okay, I know it is minus 40. So here we can take like this. Okay, this become okay minus 1 by 15 plus 1 by 40. So it is minus 40 plus 15 divided by 15 into 40. So we are getting it is equal to minus 25 divided by 600. Okay, this is your 1 by V, then V is equal to minus of 600 by 25. Okay, so you will get it as equal to 2, 4. That means V is equal to minus 24. Okay, absolutely correct, because we already have made a discussion. It will be between 30 and 15. That means it will be minus 24. That's a real. Okay, now you are moving this one by 20 centimeter towards the mirror. Okay, 20 centimeter towards the mirror. That means from 40 it become 20. So your objective position is 20 now. So let us use the same formula once again. 1 by F is equal to 1 by F minus 1 by U is equal to 1 by V. Now 1 by F is still minus 1 by 15 minus 1 by minus 20 is equal to 1 by V. So it is minus 1 by 15 plus 1 by 20 is equal to 1 by V. You can take minus 20 plus 15 divided by 300 is equal to 1 by V. So our concept is minus of 300 divided by 5. 300 divided by 5 is equal to V, that is equal to V is equal to 60. So you are getting V is equal to minus 60. So initially it was at minus 24. Now it was at minus 60. Now take the difference. 60 minus 24 is equal to 10 minus 4 is equal to 6, and 5 minus 2 is equal to 3. So your answer is 36. That means that image will move away from the mirror by 36 centimeters. So the right answer to the question number 8 will be option B. Now let us move to question number 9. A man is h feet tall. In order to see his entire image, he require a plane mirror of minimum length equal to, that is simple concept, it is half of the height of the person. Okay, that is the concept. So the right answer to the question will be h by 2. How it is? I'll show you that one here. Suppose if it is the mirror in front of you and this is the person, okay, this is the person, okay, and this person, this is his head, okay, this is his eyes, okay, this is his toe. Now the ray from the lens, okay, after the reflection, so I'll make like this, a ray is approaching, a ray is approaching the lens and bounced, so this is his in his eye. Similarly, a ray is approaching and reaching his eye, so this is his toe. This time, see here, head is also in the eye, toe is also in the cell. So this is the size of the mirror that he required. Since you know that this is, okay, angle of incidence equal to angle of reflection. Here also angle of incidence equal to theta 1, theta 2, theta 2. Okay, theta 2. These two angles will be same. So let us write here. This is T, P. Let us mark here. And this is the size of the mirror. We can mark it as AB. Now just add HT plus TE plus EP plus PT. Sorry, it is PQ. PQ. You know these two are equal. That is equal to the height of the person. Okay, height of the person. Now HT plus TE equals, so I'll make it as 2 TE plus 2 EP is equal to H. Then 2 into TE plus EP is equal to H. Then TE plus EP is equal to the okay, T plus EP is equal to the AB. So I'll write here this is equal to 2 into, it is AB is equal to H, then AB is equal to H by 2. So this is the concept that you can use. That means he wants to get at least half of his height, okay, required for the mirror to get its full image. Okay, that's the answer to the question number 9. Now question number 10. A convex lens is dipped in a liquid whose refractive index is equal to the refractive index of lens. Then its focal length. So a convex lens is dipped. So you know the formula 1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. Okay. Since it's a convex lens, then R1 and R2, they are almost same. Then when we divide, okay, consider it is something like this, you'll find. So 1 by F is equal to N2 by N1 minus 1 into here 1 by R1, 1 by R minus 1 by minus R. Okay. So you are getting N2 by N1 minus 1 into 2 by R. This is your 1 by F value. Okay. So this one once more we will simplify. 1 by F is equal to N2 minus N1 divided by N1 into 2 by R. This is the concept. Then what is F? It is equal to R by R into N1 divided by 2 into N2 minus N1. This is the concept. Okay. Usually, when we place the lens in air, N1 is 1, N2 is N. If so, F air, F of lens when it's placed in air is R into 1 divided by 2 into n minus 1. Okay. So we got the answer R by 2 into n minus 1. This is the answer to the question for the lens which we placed in air. Now see, it is immersed in liquid having refractive index equal to the index of lens. So that if so happened in this equation, F liquid equal to R into N1 is liquid, NL. Okay, not 1 now, this time. Divided by 2 into N2 minus NL. N1 become NL. Now you know N2 is equal to NL according to the question. That means F is equal to R into N2 divided by 2 into N2 minus N2. N2 minus N2 is 0. That means it will be infinite. F is equal to R N2 divided by 0, answer will be infinite. So that we can say that the focal length will become infinite in this case. So that's the answer to the question number 10 from the ray optics side. Now let us discuss some more question that is from wave optics. Let us see two slits in Young's experiment have width in the ratio 1:25. The ratio of intensity at the maxima and the minima in the interference pattern. You know that intensity is directly proportional to width, proportional to the square of the amplitude. Okay, let us mark width of the slit is proportional to intensity, proportional to the square of the amplitude. Okay, this is the concept that we have learned from the experimental setup from the Young's experiment. Okay, now see here, as per the concept we know I max is equal to root of I1 plus root of I2 whole square. Similarly, I minima is equal to root of I1 minus root of I2 whole square. These are the two results which we have got from this equation, because resultant amplitude equation is A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. This may be derived, where A1 is equal to intensity, that is intensity of the first one, then see here A square is I, A1 square is I1, A2 square is I2, 2 into 2 root I1 I2 cos theta. Cos theta, theta value depends upon, theta value is 0, cos 0 is 1, theta value is 90, cos 90 is 0. In the like that we are considering. Now see here, they are given two slits experiment have width in the ratio 1:225. Since width is proportional to intensity, okay, width is proportional to intensity, I can write the ratio of I max by I minima. So I'll write I max divided by I minima is equal to, I'll write like this, root of I1 by I2 plus 1, okay, whole square divided by root of I1 by I2 minus 1 whole square. Since I proportional to width, we can write like this, root of, the concept is 1/25 minus plus 1 whole square divided by root of 1/25 minus 1 whole square. So this is equal to 1/5 plus 1 divided by 1 by 5 minus 1. So it is equal to 6 by 5 in the numerator, and it is divided by, okay, and in the denominator it will be 1 by 5 minus 1 is equal to minus 4 by 5. So we got 6 by 4, it is equal to 3 by 2. Okay. So the square of the term is there. So minus will be there. Okay, minus will be there. Square will be there. So it is equal to 9 by 4. So the right answer to the question number 1 will be 9 by 4. So that's it about the question number 1 from the wave optics. Now question number 2. In the Young's double slit experiment, the intensity of light at a point on the screen is k. Lambda is the path difference. The intensity at a point where the path difference is lambda by 4, where lambda is the wavelength of the light used. So we know that path difference is equal to 2 pi by lambda into, so let us mark here, phase difference. Phase difference is equal to 2 pi by lambda into path difference. Okay. If so, you can write 2 pi by lambda into path difference, they have mentioned lambda by 4. So you'll get it is equal to pi by 2. Okay. Now they were asking you, the experimental setup says something about the intensity. So what happened to the intensity? So intensity I is equal to I naught cos square phi by 2. Okay. So I is equal to I naught cos square by 2. Then I naught is equal to, I naught can be I naught into cos phi by 2. I naught into cos phi means pi by 2 divided by pi 2. Okay. Whole square. Let us mark like this. So it is equal to I naught into cos pi by 4 whole square. Cos pi by 4 is 1 by root 2. That means cos 45, that is 1 by root 2. 1 by root 2 square is equal to 1 by 2. So that is become I0 by 2. Okay. Because cos 45 is 1 by 2. 1 by root 2, 1 by root 2 square is equal to 1 by 2. So it become I naught. So that is the intensity in the second case. Okay, second case. Then what is intensity in the first case? I is equal to I naught into cos square phi by 2. So there you know that the same equation you can use. Phi is equal to 2 pi by lambda into the phase difference. The initial path difference is lambda. You can get 2 pi. Okay. So cos 2 pi. Cos 2 pi means cos 360. Cos 0 is 1. Cos 360 is again 1. Cos 180 is minus 1. So that means in this case it is equal to I naught. I naught into, this is actually 2 pi. So phase to 2 pi. 2 pi means 2 pi by pi 2 means pi. So it will be minus, okay, 1. So let it minus 1, it will be I0. So it will be 1. So I0 will be the intensity. Now it become I0 to it. If I0 is equal to k, this will be k by 2. So the answer to the question number 2 will be k by 2. That is the answer to the intensity after that. Now let us move to question number 3. A beam of light 600 lambda is equal to 600 nanometer from a distant source falls on a single slit 1 meter wide and resulting refraction pattern is observed on the screen 2 minutes. The distance between the first dark on the either side of the central bright fringe. The distance between the first dark fringes on the either side. So we know that in this case, this is the case, this is the point, and this is known as the central maximum. So width of the central maxima is equal to the distance between the first dark fringes on either side of the central bright fringe. So we are supposed to get this value. And we know that As per the concept, we know that this is known as linear portion. This is equal to theta. Okay. Now, for the first minima, for minima, A sin theta is equal to n lambda, then sin theta is equal to n lambda by A. N is equal to 1, we can say that sin theta is equal to lambda by A. For small angle, it will be tan theta. So tan theta, sin theta can be theta, it can be tan theta, which is equal to, suppose if it is x by 2, overall length x by 2, this is d. Then it is equal to x by 2 opposite side by adjacent. Okay, adjacent, x by d by 2d. Now we can say that lambda by A is equal to x by 2d. So they were asking us the value of x. So we can write x equal to 2 into lambda d by A. This is the formula that we are getting. Now let us substitute here x equal to 2 into lambda value is given 600 nanometer into, then d, distance between the source 2 into 10 raised to minus 9, because it is given in nanometer. Okay, divided by A is the slit width 1 mm, which is equal to, we know that 1000 mm is equal to 1 meter. 100 centimeter is equal to 1 meter. That means 1000 mm is equal to 1 meter. That means 10 raised to minus 3. So we got it as 4 into 600 into 10 raised to minus 3 will go to numerator, plus 3 will be there, 10 raised to minus 6 will be the answer. Okay, now it is equal to 6 into 4 are 24. 2400 into 10 raised to minus 6. So we can make it as 2.4 into 10 raised to minus 9. So this is equal to 2.4. Okay, it will be nanometer. Okay, so this is the 2400. Okay, so if it is 10, sorry, it is 2.4 into 2400 into 10 raised to minus 6, which is equal to 2.4 into 10 raised to minus 3. So this is equal to 2.4 millimeter. So the right answer to the question number 3 will be 2.4 millimeter, option D. Now let us move to question number 4. The intensity at the maximum in a Young's double slit experiment is I0. Distance between the two slits is 5 lambda. What will be the intensity in front of one of the slit on the screen placed at a distance d? Is 10d, where lambda is wavelength of light is used in the experiment. So in the experiment, this is the experimental setup. So the slit is, one is here, other one is here. Okay, this distance is known as capital D. Okay, this distance is known as, is given here, that capital D is equal to 10d, and the slit width is, distance between two slits is d is equal to 5 lambda. 5 lambda. Okay, now lambda is the wavelength, I0 is, what is the, what will the intensity in front of the one of the slit on the screen placed, lambda d is equal to 10d. So we know that intensity I is equal to, usually we are considering the concept. So intensity I is equal to, so in the intensity maxima, intensity minima, there are two assumptions. So intensity maxima is equal to, the condition is, for the maxima, the condition is A sin theta is equal to 2n plus 1 into lambda by 2. Okay, this is the condition for the maxima. Okay, if so happened, okay, then this will be A into, as we discussed, it is equal to, see, this is equal to 5 lambda A x by, because we are supposed to get this distance, it is equal to a 5 lambda divided by d. Okay, which is equal to 2 into n plus 1, 2 into 1 plus 1 into lambda by 2 we are getting. So this can be D value is 10D. Okay, D value is 10D and D is lambda is equal to D by 5. So we can substitute here D value is 10D. So in this equation we will substitute A into, okay, A sin theta is equal to A sin theta. This is, okay, D, that is equal to 5 lambda. That also 5 lambda. So we'll mark here. We'll mark here. This is your screen. This is your, okay, slit. So we'll mark here. In this case, these are the two slits. This is the point which they mention, and you are supposed to get it like this. And slit width, that is A, that is equal to 5 lambda. Okay. And this is the D distance, that is equal to 10D. Okay. Now see here, in this case, if suppose you are getting the distance between two slits 5 lambda, what is will be the intensity in front of one of the slit on the screen placed at a distance D of D. So as we know that the concept is D sin theta is equal to, in case of interference pattern, Young's double slit experiment, in case interference pattern, for the maxima it is equal to n lambda, then D is equal to 5 lambda, sin theta is equal to, as we know that it is which one, this, okay, this length, okay, divided by this D. So this length is which one, 5 lambda divided by, it is coming D. Okay, this okay, 5 lambda divided by 10D is equal to n into lambda value is given there. It is approximately Young's lambda value they were asking, this is equal to 1 into lambda. So you are getting, it is equal to 25 by 10 into lambda by D is equal to, okay, lambda by D, lambda square by D is equal to lambda. So this you are getting. Now here see, this is cancelled. Lambda squares, lambda is cancelled. You are getting lambda is equal to 10D divided by 25. So this is the value which you are getting, 10D by 25. So initially how it is? Initially it is D is equal to as, okay, D is equal to as usual state 5 lambda. And of course it is, okay, so this is the concept which you are getting, 10D by lambda. That means 2 by 5D. 2 by 5D. So this is lambda is equal to 2 by 5D you are getting. And finally you know that it is just in front of the concept. So if you are considering this is the experimental setup. Okay, then in this experiment you know that this is the one of the point where you are considering, this is the point of intersection. So based on that, whenever you are considering, see the D value, the wavelength is become 2 by 5 of actuality, 2 by 5 of actuality. That means it is getting decreased. Then if the wavelength is decreased, usually that will be that a variation will be which one, less than. So that let us assume that it is approximately equal to I0 by 2. So you can substitute the condition in another equation also. In that equation, suppose intensity maxima in Young's double the condition is which one, n lambda, maxima n lambda. So that lambda they were asking, the first intensity maxima we have calculated. So in number of cases you can substitute there as D sin theta, because D sin theta is the path difference. So once you substitute the D sin theta is equal to path difference, there you can substitute all these values. Okay, then there you know that beta fringe width is equal to lambda D by small d. There's an equation for you to get the fringe width. So once you got the fringe width, so what is fringe width? The distance between the two adjacent bright and dark is not fringe. So you can use that equation also here to get the value. It is I0 by 2 will be the answer. Now let us move to question number 1 in semiconductor. When the forward So we'll discuss one more question from the semiconductor part. When a forward bias voltage of a diode is changed from 0.6 volt to 0.7 volt, current changes from 5 milliampere to 15 milliampere. Then it's a forward bias resistance. What happened? We know that it's a dynamic resistance. So forward bias resistance. Forward bias forward bias resistance is equal to delta V by delta I. This is your forward. Delta V means change in potential difference. That means 0.7 minus 0.6 divided by change in current. 15 into 10 raised to minus 3 minus 5 into 10 raised to minus 3. Okay, so this is 0.1 divided by 10 into 10 raised to minus 3. So it is equal to 0.1 divided by 10 raised to minus 2, which is equal to 0.1 into 10 raised to 2, which is equal to 10. Okay, so that your answer will be 10 ohm. Okay, so this is the concept. This is equal to 10 ohms. Okay, so this is the answer to the question number. This first one from the semiconductor, and accordingly you can continue with the second question. So that's it about this today's YouTube live of Raise Online. So till then, bye bye.